now go to another topic, because it's not only implicates our health, but also has atmospheric and ocean disruption. It's an area of active research right now, and what fact is already established that microcrystalline nanoplastics do affect the water cycle. So what does that influence involve? Like, for example, water vapor in the air does not condense into raindrops on its own. It needs some particles like to start initiators, and then they can condensate around so-called condensation nuclei. And naturally, that was like sand, sea salt, again, soot, some aerosols, but nanoplastic are present in the air in large amounts. So I remember we have visited an observatory in Austria. It was really nice place, beautiful in the really clearest, and they have a laboratory that have tracked these nanoplastic particles. That's a unique European project. That is the inventor. He did a filter that could catch even there in Alps through 3,106 meters. It was nanoplastic particle there. It rise all over the ocean. In our film, we have also show these excerpts from interview that through the atmosphere it goes very quickly. So in one place released, for example, in 2 days they have smelled in Austria the Hiroshima or some Canadian wildfire. So it is distributed very easily. And right now we see that, understand that nanoplastic particles interfere again with some normal atmospheric and oceanic cycles. Yeah, so it's an area of further research. Yes, please continue.
Yes, and another very concerning thing to me is the ocean thermal conductivity. As we mentioned before, the millions of tons of plastics, they're present in the biosphere and constantly are breaking down, smaller and smaller particles, and they have this electrostatic charge, the surface charge. You can call it surface charge for a better understanding. And they concentrate in the ocean in the three main layers. They're at the bottom of the ocean, as you can see on the picture. They're at the surface, and they're in the middle, in the area of a thermocline, where water temperature is rapidly changes. And these particles can actually interact with the surface charge, to interact with the water molecules at the level of the hydrogen bonds. And what that means is a result that physical and chemical characteristics of the ocean water can actually change. And the heat dissipation into the atmosphere might slow down. The way I imagine it is sort of like you put a blanket, like on top of the layer of a blanket. And thus, the ocean is not able to get rid of the heat and might be contributing to the heating of the ocean itself.